The music's going down. I think my microphone's on. Are we ready to go?
Yes, we
All
are.
right, we're ready to go. Hello, hello, welcome, welcome. I'm thrilled, just absolutely thrilled to be here talking to you about Nano Server. Nano Server is by far the most important, most significant change we have made in server since Windows NT. So put your seatbelts on. I'm going to just show you this fantastic new server. It is a cloud optimized server. Now I'm Jeffrey Snover. I'm a distinguished engineer and I'm the lead architect for Windows Server and System Center Data Center. And joining me,
I'm Andrew Mason, Principal PM in Windows Server.
Now here's the thing to realize. All this work, here's the man. This guy has been working on this so long, you can't believe. How long has it been?
Probably 10 years.
10 years. No, seriously. We've been doing this at various stages. It's taken the culmination of 10 years worth of effort.
It's not just me. There's a whole team working on it.
Yes. If it was just Andrew, it would have been 20 years. Okay, so let's go. Okay, so first, of course, evaluations. Make sure you fill out your evaluations. We do pay attention to those things. I don't know if you know where that. We do. We read all the comments and we respond to them, or we react to them. You know, improve based upon them. So here's what we're going to do. We're going to start off talking about what we hear from our customers. As you know, we're very customer focused. We'll talk about our server journey and then our cloud journey. Then we'll get into some of the details about Nano Server, show you some very preliminary results. These are preliminary results. Some of the numbers we have not, let's just be clear, we're very early days with Nano Server. We have not done a performance pass, okay? So some of these numbers will get better. We're not done refactoring, so some of the numbers might get a little worse. I will also tell you that as we do this, we're looking and saying, hey, maybe we should make corresponding changes to the other versions of everything's PowerShell, and the other versions of server as well. So anyway, there's preliminary results. We'll tell you about our status, our roadmap, and then actions for you guys to go do. Now, I'll also point out this talk is the developer-focused talk, okay? Next week at Ignite, we're doing a similar but different version of this talk focused in on IT pros. There's a bunch of additional content that will be released in that talk. And so what you want to do is you want to pay attention to that talk. And in particular, we're going to be releasing a lot of our demos as videos on Channel 9, and we'll show you that coming up.
All right. So what have we been hearing from our customers? Really, there's 4 big buckets. 3 of them are on this slide. So reboots impact my business. You know, why do I have to patch and reboot something that's not being used on my servers? When a reboot is required, I want my machines back up and servicing my customers as fast as possible. Then server images are too big, so they take up too much space on the disk. It takes a long time to install and configure. It takes a long time to reboot. It takes a long time to redeploy over the network. And then my infrastructure requires too many resources. So my server operating system is using a lot of resources that I could be, you know, if I'm a hoster, reselling to my customers, or could be providing more services within my organization. And by limiting the amount of resources the operating system uses, I can also increase my VM density or run more containers based on the new container functionality. The other area where we've really been hearing a lot is around security. Having more things installed, things that I don't need, obviously opens up attack vectors for attackers. And we've all seen the headlines over the last year or so, all the different attacks that have happened to major corporations. And the second one from the bottom is pretty interesting. You know, some of the hackers are attacking manufacturing companies now and actually causing physical damage to their equipment within their plants.
Yeah, by the way, sometimes we encounter customers who have this idea of like a gold image where they install everything on it and then they give it to everyone and say, yeah, just ignore the parts you don't want to do. If you're one of those people, stop it. That's a terrible idea. Don't do that.
So really what we're hearing is customers want just the components they need and nothing more. So let me install just the pieces I need for the services I want to run on that system. Don't give me, like Jeffrey said, a big gold image that has all of Windows Server installed on it when I just need a small subset.
Okay, so let's talk about our server journey. So when we started here, Windows NT, you know, really we didn't draw a distinction between what a desktop was and what a server was, right? And the joke was we took a desktop and just kind of pushed it, you know, flipped it over on its side. In fact, Mark Russinovich, you might not have heard of him. He's an engineer that works at Microsoft. Anyway, so this guy named Mark Russinovich, in fact, was the guy who became famous because he was the one that discovered, hey, the only difference between server and client is a registry key. If you change it to this, you can get a server. And so Microsoft changed it, and Mark said, oh, hey, now it's this value. And so they played cat and mouse for a while. But Mark was the guy that discovered that. And at the time, that was a great thing. When the world was all about, I walk up to this server, and I want to manage this server, it was great. It worked out fantastically because it was nice, easy to manage, et cetera. However, admin GUIs on servers are poison. They're like heroin. You know, your first shot of heroin probably feels pretty good. But you do it a bunch, your life goes to heck, and you do it too much, you're dead. Okay, now why, right? So why is it? Why are admins on GUIs so horrible? And the answer is this. Invariably, when you have a local admin GUI on a server, you put the business logic in the GUI and you call private APIs. Now what that really means is you don't have a good, proper management API, and you can't do remote management, and you can't do automation. So as long as the world stayed, I have my server, I walk up to that server, and I do it, the distinction is fine. Local GUIs are fantastic. But that world was a long time ago. Now it's about data centers, now it's about agile development in the cloud, and these local GUIs are poison. Okay, so we want to get the local GUI off. So we started that really in Server 2008, where we said, hey, now we have this thing Server Core. It doesn't have GUIs on it. Now at that point it was separate. You installed Server Core or full server, and we made some mistakes with this, right? We weren't particularly clear about what scenarios really worked well in version 1. We didn't have our full and complete management story. We didn't have a lot of the features and roles running on it when we first started. Of course, that got fixed and really nailed it in Windows Server 2012 and then R2, where we had improved our management story. All the interesting roles and features are running on Server Core, and you can choose Server Core or server with the GUI, and if you made a mistake, you can go back and forth. And that was important because some of our ecosystem still had products that required a GUI to install, and then you could take the GUI off and it would run just fine, okay? So now, that's great, now we talk about our cloud journey. Okay, so with our cloud journey, here's the thing to understand. In the context of Azure, patches are very disruptive, right? If I have to patch the host in Azure, right, and Azure doesn't have live migration. So if you patch the host, guess what? Every VM needs to be restarted. Talk about business impact, that's business impact. Next is, you may or may not know this, turns out Azure, pretty large, really large, lots and lots of servers. Well, you take a large number of servers and you say, well, hey, each one of those OSs consumes a bunch of resources. A bunch of resources times a bunch of servers, that translates to a large number of cogs. And of course, taking these large images and moving around the network consumes a lot of bandwidth that we'd rather be serving for other people. Now, as you know, Windows Server has something called Cloud Platform Solution. Cloud Platform Solution is server or cloud in a box, 1 to 4 racks. And so here we have live migration. It's fantastic, right? So if I have to patch the host, I go, no service interruption, right? You will drain the VMs from one machine, we'll patch that host, we'll move them back and iterate through all the hosts, okay? But in a 4-rack system, I have 8,000 VMs. At 2 gigabytes each, that means I'm live migrating 16 terabytes of data. 16 terabytes of data across the network that should otherwise be servicing customer needs. So even though I don't have service interruption, I still have a pretty large service impact. So what I'm getting at here is that the cloud really can't withstand these interruptions, right? So ultimately what we concluded was that we needed a server configuration optimized for the cloud, okay? Now I mean this literally. We need a server configuration optimized for the cloud. I'm pretty sure you need it as well, but I know that we need it. And that is what Nano Server is.
Yes, so Nano Server is our next step in that journey. And so what it is a new headless 64-bit only deployment option for Windows Server. So back to Jeffrey's comment about GUIs being poison on a server. It is headless, there is no local logon, no local interface to it. There is no RDS into it, so you cannot terminal server into it. You do have to manage it fully remotely, and we'll talk about that in some more detail. And it is 64-bit only. Again, that helps shrink the footprint. And it is part of Windows Server. So it is a deep refactoring focused on the Cloud OS infrastructure and new born-in-the-cloud applications.
It's worth pausing here. I want to be really precise. We're early days in Nano Server. This is version 1 effectively, and we're focused in on these two scenarios and these two scenarios only, okay?
And over time, more will come, but we're focusing on these two for now. And we're following the server core pattern. So what that means is it's a separate installation option like server core was back in 2008 and 2008 R2. So you have to make a choice during deployment time if you're going down the Nano Server path or if you're going to deploy server core or server with the admin tools.
And of course, we're learning some of the lessons we learned from server core. Yes. We're being precise about the scenarios we're after. The benefit of that is I can go to you and I can say, hey, you're part of the scenario. I need you to stop what you're doing and do this work. And somebody else can say, I'm going to talk to you later. Right? So it allows us to focus in on that. Next is we dramatically improved our manageability story. You'll see all about that. And we're working with partners. So,
and improved our developer story over what we did with server core, which is coming.
That's right.
Yes.
How could I forget that?
Don't forget that. So as far as Nano Server roles and features go, we've moved to a zero footprint model. So if you're familiar with Windows Server or Windows Client today, when you install it, there's a side-by-side folder where all the optional roles and features live. So they're all taking up disk space on your servers and in your virtual machine images. With Nano Server, we've removed all that. So there's separate packages for the roles that you can install. You have to install those as part of your deployment process. So if you later on go to install a role on the system, you have to go off and find the bits to actually install it. It's not on the machine.
Boy, does everybody aware of that? Right, so have you noticed you go into a server and you say, hey, I'd like to have IIS installed, and it doesn't say, please insert the media, right? And the reason for it is when you installed stuff, we installed everything. We didn't install it. We put everything on disk, and it's just off on the side. So when you say, I want to install it, we just take it from the side and we bring it in. Okay, that is not how Nano Server works. That's one of the reasons why the images got so very, very large.
Yes. So the roles and features we're targeting for the Cloud OS scenarios and the born-in-the-cloud applications are Hyper-V, storage server, and clustering. So that's for your host OS. And then for your app platform, your born-in-the-cloud apps, we have the core CLR, which we'll talk about a little more, ASP.NET 5, and the PaaS framework. And then we do have full Windows Server driver support. So if you have a piece of hardware that you have a Windows driver for, that same driver works on Nano Server. Same driver stack, same everything, same set of drivers work. So you don't need different drivers for Nano Server. We do have anti-malware built in, so Defender is included in the Nano Server image.
Yeah, by the way, that's all versions of Server now come with anti-malware on by default.
Right. And we don't have, like Jeffrey said, we're still early days in this. We're making progress here. We're still working on bringing in the System Center agents. So we're working on VMM and Operations Manager, and we're working to bring in Apps Insight and some of the other agents for the Microsoft products, as well as reaching out to ISVs to make sure their software works on Nano Server.
All right, so now let's talk about the management of Nano Server, okay? So the model here is we want to eliminate the idea of you ever sitting in front of a server managing it, right? Gone, don't do it. Really have this configuration, you do all your configuration through PowerShell desired state configuration, and you do all the remote management through core PowerShell. Notice I didn't say PowerShell, I said core PowerShell, watch that, and through WMI. And then you want to integrate into the DevOps tool chains and the DevOps mindset, okay? The DevOps mindset said we want to be able to manage servers like cattle, not pets, okay? In the old days, right, if you're familiar with this, in the old days you used to treat servers like pets, right? You give it a name, a precious name, and if it got sick, you cared for it and you tended to it, etc. With cattle, you don't give them names, right? You give them numbers. When they're sick, you fire up the barbecue, right? It's just a completely different model, okay? And you're really focused in on the herd, not any individual. Well, that's the way you want to, that's really the cloud model, okay? So you want to develop this DevOps mindset. And so if you're developing products, you really want to get that model in focus. Is not about getting a thing up and running and keeping it running it forever, okay? Okay, so now let's talk about Visual Studio Release Management. Right, are you all familiar with Visual Studio Release Management? Great DevOps tool. Can we get the audio?
To the Nano Server.
Right.
The app that we have in question is a simple. Hi. In this video, we shall look at the capabilities of a Nano Server to host a website and the integration with Visual Studio Online toolset in order to deploy a new code to the Nano Server. The app that we have in question is a simple website called Hot Coffee, which the team has developed and checked it into Visual Studio Online. The team manages the build for this app using the build preview feature into Visual Studio Online. The team has already built the solution and is looking to deploy the same to a Nano Server. The release manager in question decides to flight this through a dev environment before hitting the production Nano Server. In each of the environments, a PowerShell task is used, which is executing the deployment script against the target environment. The release manager triggers a new release and waits for it to finish. The release to the dev environment is now done and is waiting for an approval from the release manager. The release manager browses through the website deployed on the development Nano Server and validates the content. He notices that there's a typo that's been created in the title and logs a bug in the background for the release team to fix. He comes over to the release and decides to reject the currently running release while the bug is fixed. The team makes a check-in for the bug fix and triggers a new build. As the build is finished, the release manager would notice that a new release would get triggered automatically for this particular deployment. This happens courtesy the background plumbing that's been done while defining the release definition to trigger a release on completion of the build for this artifact. With the release done and waiting for approval again, the release manager goes and updates the portal on the Nano Server against the dev environment and notices that the bug is fixed. He is good to now let the bits go. Post approval, the release would now repeat itself on the production Nano Server and deploy the bits to the external world. Thank you.
All right, so what you saw there was Visual Studio Release Management. So it's a DevOps mindset, right? You build your product, you put it into a release management pipeline where it's tested, it's deployed through automatic systems, use desired state configuration and management. When you have a chain, you just do that again. Notice, at no point did somebody RDP into a server and bring up a GUI, right? Now let's think about this. Why is that, right? So imagine you go and to provision a system, you say use a GUI and you 500 clicks later you got your system, okay? And now you got to do it to 100 more servers. Like, are you really going to get 500 mouse clicks done in the same order 100 times? Answer, no way, right? So that's why you want to automate things. You want to script things so that, hey, if you get it wrong, just go change the script. Get it wrong? Change the script. Get it right? Great. Leave the script alone because you got it right. Then do it over and over and over and over again. High quality DevOps operations with Visual Studio Release Management. So I mentioned to you that it uses PowerShell, core PowerShell, and not PowerShell. What is the difference? The difference is that PowerShell is based upon .NET and core PowerShell is based upon the core CLR. So just as we have refactored full server, we are refactoring PowerShell. We're refactoring PowerShell to run on the core CLR. It has the full PowerShell language, right? The compatibility, remoting, so invoke command works, expressions work, new PowerShell session, new enter PS session, all that good stuff works. Most of the engine components are there. The one significant engine component that's not there is Windows Workflow. That's okay because Windows Workflow can run on another machine and still manage Nano Server as a managed element through the magic of PowerShell remoting that's directly integrated into the model. Supports all the different PowerShell commandlet types, so C# commandlets, script commandlets, and sim commandlets. Thing to note, the C# commandlets work if you have the underlying support for it in .NET. Remember, you do not have the full .NET, you have the core CLR, the core, .NET Core, I think we're now calling it. So if your commandlets call GUI stuff, ain't gonna work on Nano Server, okay? Most of the manageability commandlets don't do that. And we are starting off with a limited set of commandlets and moving very rapidly.
So to the earlier point about the GUIs being poison and Server Core being a first step at this, we heard the feedback on Server Core that there's a lot of things where people still have to RDP into the server because there are tools that only run locally. There's configuration you can only do locally. So we're doing a lot of work to change that both through core PowerShell as well as we're developing a set of remote server management tools. And so these tools are going to be web-based and they're designed to replace all the things that you would normally need to log in locally or RDP into a server to do today. So everything above the line we have working today. So we have a remote task manager, we have registry editor, we have event viewer, we have device manager, we have sconfig if you're familiar with that. That's the initial configuration from Server Core. And so that sort of overlaps with some of the control panel pieces. So we have some of that working today remotely. And so all of this is available as a remote GUI so you can remotely manage your servers if you're not doing the automation for your herd of cattle.
Yes. By the way, you definitely want to see this. We currently don't have, there's so much to talk about. We don't have time to show all this stuff. This is one of those stunning demos because it uses the Azure portal framework. And so we're definitely going to show it at Ignite, and it's definitely going to be on Channel 9 afterwards. You'll want to put a bookmark in your calendar and go watch this stuff because you will be stunned. It is wonderful. I don't know about you, but whenever I hear web GUI, I think, oh, compromise. No. This is not. This will blow you away.
Yeah, and the great thing about this is, as Jeffrey mentioned earlier, running GUIs locally, a lot of times you have private APIs, you have business logic built into those GUIs. Well, in this case, this is all layered on top of PowerShell and WMI. So we're getting additional WMI providers put into the product, and they're both in Nano Server as well as Server Core and Server. So in addition to being able to use this new UI to manage the system, you can script it all using PowerShell. You could write your own tools that interface with this and display your own GUI. So we're separating that out and doing it the right way.
Doing it the right way.
Yes. Now on the cloud application platform side of things, like I said, we're focused on the born in the cloud application support. So we do have a subset of Win32. So some existing Win32 apps will run on Nano Server, and I'll talk more about that. Jeffrey said the core CLR, PAS, ASP.NET 5. And it will be available everywhere. So you can deploy Nano Server as your host OS on your physical machines.
Before we go there, it's worth just like pausing and letting that sink in. So Nano Server is a version of Windows Server, okay? So it's API compatible. All the APIs in Nano Server are the same APIs that are in full server. There are just fewer of them. APIs to put things on the desktop, they don't exist. So don't write, server applications shouldn't be doing that anyway, so that's fine. A lot of server applications will just run fine. Sometimes you might have to refactor to use the version that's in Nano Server versus something that's in the desktop version. But we want to be clear about this. This is a version of the Windows Server you know and love.
Yes. And it will be available everywhere. So you can deploy it as your host OS on your physical machines, for your Hyper-V host, your storage host. You can run it as a guest OS in a virtual machine to run your ASP.NET or Core CLR-based apps. And it will also be the base OS for both flavors of containers, the Windows Server containers as well as the Hyper-V containers. We are working on some future additions. So PowerShell desired state configuration is not actually in the build that's going to go out as part of Build and Ignite. And we're working on package management, which used to be called OneGit. And we're also looking at adding additional roles and application frameworks as we take our journey through to releasing Windows Server V next.
Yeah, so the desired state configuration will follow shortly, just a timing issue. And if you're not familiar with it, this thing we used to call OneGet, until some guys decided to ask the lawyers if that was okay to use. So then we ended up with PowerShell Package Manager. Anyway, so Package Manager is a wonderful tool. It allows you to go on any machine and say, here's the software that I would like to get running on this machine. And then we'll find it at various repositories. And you can declare which repositories you trust and which ones are untrusted. And if you pull something from an untrusted repository, we ask about it. You can set up your own repositories with your definitive software libraries in them. So you put things there and then go to machines and say, install this, and we just find it and install it. It's wonderful, wonderful stuff. Okay, so let's talk about the server application development, okay? So now the question is, okay, I'm a developer, and I kind of get this server thing in focus, and now you're bringing up this Nano Server. Like, how do I think about it? And then the question I get a lot is, like, so do I code to containers, or do I just code to Nano Server, or do I have to choose? It's actually a very simple story, okay? So here's the model. What we're doing is a deep refactoring of the server, okay? We start off with Nano Server. That's the core elements. On top of that is server. Now, we used to call this server core. That was a misstep. This is the server. Because the other thing we used to say was there was server core and there was something we used to call full server. That sounded like a good thing, right? You're going to buy a server application. Somebody says, oh, well, I require a full server. And you're like, wow, you must be great. No, it wasn't great. And then we tried to be clear about it. In the last version, we said, well, no, it's not full server. It's server with a GUI, okay? We want to get even clearer. The future name is going to be client, okay? Because that's really what it is. It is a client stack running on a server. Now, that's what it is. Mary's shaking her head. That's what it is. It's a client stack running on a server. Now, there are times when you want to have a client stack running on a server. When are those? And the answer is remote desktop. Remote desktop is a client stack running on a server. So there are definitely legitimate cases for this. But most server applications should not be using a client stack on a server at all. Okay, so the model is going to be that as a developer, I code to server or Nano Server. I'm going to bring up Visual Studio, and I'm going to pick these, you know, I just say, I want Nano Server, I want full server. You are not going to code to the client. That's not for you server guys. That's for the client guys. Go put that on a client, not on a server. Next, so a developer targets server for compatibility or Nano Server for cloud optimization, and then they hit F5, they get an exe. Now they have to deploy the exe to run it. And here's where it becomes very simple. You pick which one you wanted, server or Nano Server, you get your exe. Then you deploy it on a physical server, in a VM, or in a container, Windows Server container or Hyper-V container. Okay, so it's a very simple story. A server and Nano Server are a set of APIs and components, and then they run somewhere. They run on a physical machine, they run on a virtual machine, they run in a container. That's simple. Okay?
One thing to point out there, the client server does not run in a container. You can only run that on physical or virtual.
Thank you. That's important.
You want to run a container.
Yeah, so we're being pretty pointy here. So if you've got a server application that uses some of those client APIs, they ain't running in containers, so stop that practice. Okay, oh, so now we got ASP. So now here what we're going to show you is ASP.NET 5 running the music store demo running on Nano Server. The key things to point out here are how much stuff is running today on Nano Server. Pretty great.
Right, and this one also shows remote debugging.
This is the ASP.NET 5 Music Store application running on the Nano Server. The Music Store is a lightweight sample store implementation which sells music albums online and implements basic site administration, user sign-in, and shopping cart functionality. The entire application is written on the ASP.NET MVC framework and uses Bootstrap on the client side to present the user with a modern and responsive user interface. First, I'm going to use the store as a regular user. I'm going to browse the store, see the available albums, and add one item to my cart. Next, I'm going to add another album. Behind the scene, the information is stored in a SQL database, and it is accessed using Entity Framework. Once I have a few items in my cart, I can proceed to checkout. ASP.NET 5 supports many sign-in providers including Microsoft, Twitter, Google, and Facebook, and even though not shown here, OpenID and Azure Active Directory. For this demo, I'm going to log in using my Twitter account. Once logged in, the music store asks for the shipping information. Once the shipping information is filled in, I can type in the free promo code to not have to pay anything for this order. The order is now complete and I can continue browsing the store, or I can log off. Now I'm going to show you how you can debug an ASP.NET 5 application running on the Nano Server using the Visual Studio Remote Debugger. I have already started the Remote Debugger on the Nano Server machine and opened the Music Store solution in Visual Studio. Also, I have set a breakpoint in the account controller, the register method. This code is executed when a new user is registered. First, I will attach to the remote process. The nx.exe, or the .NET execution environment, is the process hosting the Music Store application on the Nano Server machine. I will attach using core CLR. Now that the debugger is attached, I will go back to the Music Store application and try to create a new user. When I press the register button, the breakpoint will be hit and I have access to the full Visual Studio debugging experience. I have access to locals, call stack, modules, threads. I can step through the code, I can step in the code, and I can even change the position of the execution point. As you can see, debugging a core CLR application running on the Nano Server is no different than debugging a local .NET application. If you'd like to know more about the Music Store application, you can go to github.com/ASP.NET/MusicStore and get the source code.
Great. So there you saw ASP.NET. What do we have? We had SignalR, we had any framework, we had the model view controller, access to all sorts of authentication systems, all running on Nano Server, and a very rich graphical remote debugging experience. Okay? So Nano Server doesn't mean no GUI. Nano Server means remote GUI.
Yes. So let's talk some about the developer experience for Nano Server. So for those of you that tried to get your code running on Server Core, we didn't have a great experience there. You had to go to a web page on MSDN that listed the APIs that were supported. And it was painful. There were some unclear areas where what was supported and not supported. So we've really taken a different approach with Nano Server. So we've fully integrated it, there we go, with the Windows SDK. So when that comes out with the Windows 10 client, you'll find Nano Server in there. We've got it as a target in Visual Studio 2015. So there's a template in the gallery that you can go download that will allow you in Visual Studio to target Nano Server and actually see if an API you're using is supported or not on Nano Server. So we have a rich design time experience, fully integrated. Like I said, the project template, you get full IntelliSense. So if you try using an API that's not supported, you'll get the little red arrow squiggles underneath it. And we have full remote debugging experience. We saw the ASP.NET debugging experience there. We do have full debugging support through Visual Studio. So we have a demo showing that running as well.
This is a quick look at the Nano Server developer experience. First off, we're introducing a downloadable project template that will pull in the right headers and libraries so that you can get first-class IntelliSense and arrow squiggle support when developing a Nano Server application. Note that any application that runs on Nano Server will automatically run on Server Core and Full Server. Once you create a new Nano Server application project, you'll see the landing page with a short, helpful FAQ. For example, you'll see that Nano Server doesn't support WoW, so you'll want to select x64 from the debug target dropdown. For this demo, we're going to use an existing MSDN sample and compile it against Nano Server. The sample is called Accessing Remote Computers. Once we copy and paste the code into the Visual Studio Editor, we replace the main function with _tmain. Notice the code's dependence on the WebTAPI library, so let's add it to our project. Right-click on the project node in Solution Explorer and select Properties. Go to Linker, Input, additional dependencies, click Edit and enter the WebTappy library. Let's build our app and run it locally without the debugger to see its output. We see a list of registered providers. Now, let's run our app on the remote Nano Server machine. We already have a Nano Server machine running in a VM, and we've prepared the PowerShell commandlets we need in the PowerShell ISE. Then we use copy items to session parameter to copy our executable and symbol file, the PDB file, to the remote Nano Server machine's C test folder. While we're at it, we'll copy the IP address before we switch back to Visual Studio. Now we need to tell our project about our remote machine. So bring up project properties again, go to Debugging, Remote Windows Debugger, and change the working directory to the remote machine's working directory using the IP address. Change the remote command to run nanoserver application2.exe in the working directory. Change the connection type to remote with no authentication, and change remote server name to the IP address. After we set a breakpoint, we hit F5 to start the remote debugging session. For the purposes of the demo, I've already started the remote debugger on the Nano Server machine. The debugger stops at the breakpoint, and we immediately notice the updated values in the locals window. You can step through code, set watches, and continue debugging exactly as you would in the local debugging case. Now let's try IntelliSense. Let's type in get file version info, and we see that only the EX versions of the API are supported. If we try to use an unsupported API by removing the EX, for example, we immediately get the red squiggles. In this demo, we caught a glimpse of the Nano Server developer experience, starting with the project template, IntelliSense, and error squiggles support, all the way to a full-fledged remote debugger. Now you have a first-class developer experience to write some really cool tools on Nano Server. Thanks for watching.
Now, if you notice that, so he started off with the template, picked a Nano Server project, gave him full support for that. When he produced the exe, you notice he went into PowerShell and he did a copy. So we've updated PowerShell, so now you can do file copies from and to remote computers. And so that was something he was highlighting here.
Right. And I don't know if you picked up on one of his comments early on about compiling the code. If you target Nano Server, your same code will run on server core and server. So you can create one executable that will run anywhere in the server family. And so he talks some about the different versions of the APIs. So as we've talked about, Nano Server is a deep refactoring. So we've removed a bunch of DLLs that provide higher level functionality that aren't needed in Nano Server. But what we've had to do is pull some APIs out of those. So there's some common APIs that are used by a lot of apps. When we looked at the various roles we want to run on it and some of the applications we want to run on it, there were APIs that lived in some of those things we removed that are needed in Nano Server. So we've pulled those down and put those into new DLLs. And so what we've created are a set of reverse forwarders. So if you already have a set of code that runs in server core today, if that runs within the boundary of Nano Server, that will run today on Nano Server. So what a reverse forwarder does is it puts a version of the DLL in Nano Server. So when your code loads, it looks like that DLL is available in Nano Server. And when the API gets called, it gets forwarded down to the new location where the API actually lives in Nano Server. So you don't have to necessarily recompile against Nano Server if your code is already within the boundary of Nano Server. And so this provides a way for you to get up and running quickly on Nano Server with existing code. And so when you run with a reverse forwarder, what will happen is the API call is either going to succeed if that API is within the Nano Server boundary, or you'll get a return code of error not implemented. So you know that that API is missing in Nano Server. Now, we're still doing a lot of work with the reverse forwarders, and so there are additional APIs we're going to keep pulling down. So the build of Windows Server that's coming out soon doesn't have all the reverse forwarder work done in it. The next technical preview after this one will have even more of that. But if you are working with your code on Nano Server and you come across some APIs that you think would be useful to have a reverse forwarder for, there's an email address at the end of the presentation. Send us that list of APIs so we can keep working on factoring and getting the right set of functionality in Nano Server.
Yeah, so it's worth pointing out how we developed Nano Server. So what we did was we started at the very smallest component that could run. And then what we did was we picked the scenarios that we wanted to run, and then we figured out what APIs needed to be refactored to support those scenarios. And then we did the next scenario, and the next scenario, and the next scenario. That's why we're so clear about the scenarios that version 1 supports. CloudOS infrastructure, clustered hypervisor, cluster storage, born in the cloud applications, ASP.NET, etc. As you go and take your applications and get them on Nano Server, as you encounter problems, we'd like to hear about it so we can decide, hey, are those part of the scenarios we want to focus on version 1? And if so, then we'll find out those APIs and we'll refactor them. If those are scenarios that we're not targeting for version 1, we'll say perhaps later.
Put it in the backlog.
Put it in the backlog.
Yes. So that's one of the big differences with Server Core and Nano Server. With Server Core, we tried to play and plug into everything that existed out there in the ecosystem of Windows Server. With Nano Server, we're taking a much harder line, saying we've got this dividing line and only certain things are going to be functional on there. We're not just going to keep piling stuff in just to let it play with what exists today. So key point I want to stress with reverse forwarders is they do not eliminate the need to refactor your code for Nano Server. So if you're calling an API that doesn't exist in Nano Server and it's not something we can refactor and bring in, you're going to have to adjust your code. To Jeffrey's GUI example, if you're calling something that pops up a message box, that's never going to work in Nano Server and you'll have to change your code. Now the reverse forwarders are an optional package, so they're not installed by default, but if you do need to run something that hasn't been recompiled for Nano Server and adjusted to where the DLLs live now, or the APIs live now, you can install them in your Nano Server image. So when you get Nano Server in the upcoming Windows build, you'll see a packages folder that has a reverse forwarders package in it. And what we have today is this list on the screen. So a lot of higher level functionality that often has common APIs for like file and registry and things like that, that you may need for your apps even running on a small footprint server like Nano Server. And we've done a bunch of work and experimented with a variety of things. And
Dude, you're stealing my slide.
I'm sorry.
Yeah, this one's
Doesn't
mine.
have a little red dot.
I know, I screwed up.
All right, you can have that one.
All right. So here's the thing. We mentioned born in the cloud applications. We talked about ASP.NET, PaaS, et cetera. That's just the beginning, right? We want to support all the language runtimes. If people are writing cloud applications in a language runtime, those are the ones that we want to support. And so we're doing that. We're actively working that. So here's what runs today. Many of these with the reverse forwarders, but here's what runs
What runs today. Yeah, we keep talking about Core CLR and ASP.NET 5,
Yeah.
but there's a whole bunch more.
Check this out, okay? So we've got Chef. Chef uses Ruby. We've got PHP. We have Nginx, Python, Node.js, Go, Redis, MySQL, OpenSSL, Java, Ruby, SQLite. And that list will continue to grow. This is very exciting. Very exciting. So if you're writing a CloudOS, a cloud application, and there's something you're writing in some language that's not here, let us know, because we want to support that.
Right.
Okay?
And again, this is with the reverse forwarders installed. If you just take the Nano Server image and don't include the reverse forwarders, a lot of these aren't going to run.
Yeah. Okay. So again, I mentioned CloudOS applications. Part of that is the DevOps tool chain. Earlier, we showed you a demonstration of Visual Studio Release Management. That's Microsoft's DevOps toolchain. Chef is another great partner that has a DevOps toolchain. So let's show you that running on Nano Server. You got your seatbelts on, right? Okay, good. You're gonna like this.
No.
No, don't.
Okay, you could have done it that way. That's fine.
No, where'd it go?
Go to the desktop.
Here, why don't you do it?
I was trying to.
Hey Adam, thanks for coming in from Chef. I appreciate it.
Yeah, you're welcome.
You've seen demos of Nano Server before, haven't you?
I have. Nano Server is fast.
Yeah, what do you think? Isn't it awesome?
Yeah, in fact, I would love to see Chef running on Nano Server.
I would too. That makes two of us.
Yeah.
How can we make that happen?
Well, we could write a few recipes, like pick a demo, maybe open source stack like Django, Python, and we'll write the recipes and make sure we get Chef working on Nano Server.
That'd be really cool. Can we count on your support?
You totally can. We've done a lot of Microsoft integration before, so I'm looking forward to doing some more.
Excellent. Let's just go do it.
All right.
Hello, everyone. Here's an early demo of Chef configuration management running on Nano Server. Chef is used here to run a simple web app built with the Django web application framework and using Nginx as a reverse proxy server. Chef provides the recipes for configuring Django, Nginx, and Python, which, as you know, is what Django runs on. We start by using PowerShell remoting to remote into the Nano Server machine. We'll change directory to chef64bin and run the chef client. Let's just go ahead and fast forward this part, and we're almost ready to run our web app. Before we do, I need to copy the IP address and paste it into Internet Explorer and use port 80. This is a simple web app that helps manage polls, so I'm going to create a sample poll. After entering my credentials, I'll choose the commute poll and enter car, just because I love driving. Let's take a quick look at the Django recipe. For that, I'm going to leverage PowerShell ISE's cool new feature of editing remote files. This same chef recipe can be used on developer systems and within continuous integration workflows to deploy the application to various test and staging environments. That's it. In this short early demo, you saw how Chef, and therefore Ruby, Django, Python, and Nginx all ran on Nano Server. This server may be nano in size, but certainly not in power. Thanks for watching.
There you go. So now again, what he highlighted there was PowerShell has now the ability to do remote script editing and remote script debugging, again, to support, what you'll find is that as we modify the system to support Nano Server, it makes the rest of our system better. In the same way that when we went and focused in and decided we were going to become a great enterprise server, that was at a time when somebody said that the defining user experience of the desktop was something called the blue screen of death. Okay, but our work on the server, when was the last time you saw a blue screen of death, right? They happen, but they're pretty rare. And why is it? It was because our investments in the server benefited our desktop. So too, our investments in the cloud are changing things so that they will benefit the enterprise scenarios as well, like full remoting. All right. Oh.
So before we go on to installation, so we worked very closely with Chef on that demo and actually found some APIs that we moved down from up above into the reverse forwarders to get everything working on there. And you may have noticed in that demo and some of the earlier ones is everything 64-bit. So you do have to make sure your code is 64-bit to run on Nano Server. So if you do find things that are 64-bit APIs that you need moved down, please let us know and we'll take a look at those. So installation on Nano Server. I mean, we saw that cool demo just then, but Nano Server does not have MSI support. That has a lot of GUI dependencies. It's not available. So in today's builds, the installation options are Xcopy your files over and manually do the registration or create some custom PowerShell scripts. Now we are working on an installer for Nano Server so that you can package up your code and be able to install it. And we're looking at supporting install, uninstall, inventory, and both online and offline installation of code. So the supported tasks we're going to have are for files. So you create and delete folders, copy and delete files, set permissions on those. We will have services support, so configure, start, delete. We will do com, register, and deregister. We will support registry, so create and delete registry items. And we will also support ETW event registration, which is a custom action in MSI today. So focus down on the scenarios that we believe are needed to install code on Nano Server. But again, if there's functionality here that you need to install something, please let us know and we'll look into that.
And just to be clear, we're drawing a distinction between installation and configuration.
Yes.
Turns out that a lot of the problem is when you get those two things confused. You want to install something, and then you want to configure it. Those are different things, and you can install it using this or Xcopy, and then you configure it with things like desired state configuration.
Exactly. So we've talked about a lot of stuff. It all sounds very exciting. Jeffrey mentioned we talked about some preliminary results. So these are early numbers. Again, things may change as we keep evolving the system. And some of the things we find and make better in Nano Server may make Server Core better as well, which would be great. But some of these numbers may change. So how are we doing with all this stuff we're talking about? So first is we're going to look at servicing, and this is all the patches released during 2014. So if there had been a version of Nano Server available throughout the year of 2014, how did it compare with Server Core and the server with a GUI?
Yes, so just to be clear, we did the code analysis of every single patch in 2014, and then we mapped it to the code base and said, does that code base exist in Nano Server? So basically, we did it the right way. There's no gamesmanship going here.
Right. So Nano Server would have had 9 important bulletins compared to 23 for Server Core and 26 for full server. So critical bulletins is even more interesting. So only 2 critical bulletins for the whole year for Nano Server. Server Core had 8, full server had 23. 2, yes. And then the number of reboots, 3 reboots the whole year. Server Core would have had 6, full server would have had 11. So you would have only been able to skip 1 month's worth of reboots. So you can see that greatly increases your uptime, and we still want to do some more work. We really want to get this to a maximum of 2 reboots a year for Nano Server. On the security side, so the drivers, we haven't done a lot in this area yet. It's lower, 73 compared to 98. But then the services running 22 versus 46, so a little less than half. Ports open, 12 versus 31, so a little more than a third. So significantly reduced the number of services and ports. Those attack vectors that all those hackers we talked about earlier love to try and access. Resource utilization, so the process counts 21 versus 26. Boot I/O, 150 megabytes versus 255 megabytes. So we actually have a Nano Server on an old tower machine in somebody's office booting in 15 seconds. It's a pretty impressive improvement. Kernel memory in use, 61 megabytes versus 139, so about half.
That's less than half, my friend.
I know. So deployment improvements, this is very interesting along with the patches. So from starting the deployment process to fully provisioned and accessible on the network Nano Server, 40 seconds. That's setting the computer name, getting a DHCP IP address up and running and accessible. Server Core took 5 minutes. So we also have a setup, and it's a demo that we'll get up on Channel 9 after Ignite, of Pixie booting a Nano Server machine, and this is on 2 old tower machines with a 100 megabyte switch. Nano Server takes 3 minutes to deploy from starting the Pixie boot process to up and fully provisioned. And that's on a 100 megabyte switch with some old hardware. I'm sure in a data center environment, you'll get that even faster. We did the same thing with Server Core and that same equipment, 19 minutes. So the Nano Server time, actually, we've done some analysis, a lot of that time's actually spent copying WinPE over. So we've got to do something there. But then disk footprint, this is where it gets really good. So Nano Server is 400 megabytes compared to almost 5 gigabytes for Server Core.
Oh. Wait for it.
And then on the VHD side, there's a little bit of overhead in the VHD. You can see Server Core goes from 4.8 to 6.3. Nano Server goes from 400 to 410. So great improvement in footprint. Back to the comments we were making earlier about the smaller installation size, needing faster reboots, all of that, we're getting there. Yeah,
so what I like to tell people at this point is, you just saw those numbers, pretty stunning numbers. The next time you have somebody, a developer or an admin say, well, I really don't want, it's inconvenient to learn PowerShell. I really don't like the local remote GUIs. Think back at these numbers and then look at that person and say, is that person really worth 4 times as many reboots, that much extra resource consumption, and that much extra time? And the answer might be yes. I don't think so.
So Nano Server and Windows Server vNext. It will be an installation option much like Server Core. Now it will not be listed in setup. So with Nano Server, one of the ways we get it so small is you have to put the drivers in. There's no plug and play, or user mode plug and play in Nano Server, there's kernel mode. So it's not gonna go off and detect what drivers are required for your particular hardware. You have to inject the drivers into the image before you deploy it. So rather than it showing up in setup and if you haven't put the drivers in, basically installing a brick, it is a separate image that you have to customize before you deploy it, so it's in a separate folder on the media. And under that, there's a packages subfolder, and in there is an OEM drivers package, so if you want to take all the drivers available in Server Core and just put that big blob in, you can do that, or you can customize it and just pick the drivers specific to your hardware and have a very small and tight image. And it will be available in the next server release, being released as part of Ignite and Build, and then in the follow-on technical previews. So we're going to get a guide up on TechNet on how you can work with Nano Server, how you can do remote management through PowerShell remoting, and all of the information about how to inject drivers and things. So that's all coming.
Yeah, and it's worth, again, reminding you that we're very early days with Nano Server, so when you get it, you know you're going to have to read the release notes, you're going to have some struggles, but we'll have some FAQs out there, some video demos, but obviously, each release will become more polished. Okay, so the roadmap. So Nano Server is the future of Windows Server, okay? Version 1, we're starting focused in on these cloud scenarios, okay? And then, you know, there's Nano Server and there's born in the cloud applications. But it's really the foundation for all the components going forward, right? We want a model of just enough OS. So if you're writing an application and you need 5 gigabytes worth of components, you know, great. You should have 5 gigabytes of components. But you shouldn't have 10. And if you only want 900 megabytes, you should only have 900 megabytes. So you'll see that Nano Server, starting off with the cloud scenarios, is a first step to a fully compositional factored operating system where you get the components that you want.
Right, and we'll keep moving roles over to Nano Server. So if you have particular roles that are important to you, we're collecting feedback on that to prioritize what we go after next after Hyper-V and File Server.
So you get just the things you want, as long as you want the right things.
Yes, as long as they don't require GUI.
Exactly, as long as it doesn't require GUI. Okay, so we do have Server Core, and that will run your existing enterprise applications for now. And again, both of these, you'll run these, you'll decide which one you want to target, and then you'll run it in a physical, in a virtual, or in a container. Okay, it's a pretty simple story. Okay, so the actions. Retarget your code for Nano Server. It's the future. You want to get on this. You want to get on this. We think people are going to adopt this pretty quickly. You saw the numbers, right? They are compelling. They speak for themselves. As I mentioned, this is the most significant change we have made to the server since Windows NT. So you want to get on this bandwagon and help us, right? Tell us where we're not doing things. So deploy it. Let us know what encountered, any problems that you have. Here's the thing. And you want to shift to full remote management. Now, I know some of you have not done this. Stop. Embrace remote management. That is the future, full stop. And you should do it both for Nano Server and your other products. It's the only way our customers, our mutual customers, can adopt in scale, right? Can automate, can improve their IT. So do that. Here's a great set of resources. How are we doing on time?
We've got a couple minutes left.
Okay, we saved one demo for the end.
Sure.
Because we weren't sure we were going to have enough time. So this is PowerShell. We got Nano Server running as a VM instance in Azure, and we then use remote PowerShell to manage it.
Yes. And all these videos will be on Channel 9 this afternoon, and more will come after Ignite next week.
At the end of the demo, we'll show you the Channel 9 page so you can see it.
Hi everyone, I'm running Nano Server and a VM on Azure in the cloud, and in this demo I'd like to show you some of PowerShell's cool new features running on Nano Server. Once I've located my VM, I use the dashboard to locate the public IP address and copy that to the clipboard and paste it into the PowerShell ISE. Let's store that value into $IP. I also need to create a session object using new PS session and passing in the $IP as the computer name, as well as the administrative credentials. This session object is going to come in handy throughout the demo. For starters, let's use it to remote into the Nano Server VM using enter PS session. I use -session now that we have a session object and pass in $S. Once I'm in, let's change folders to C test and do a dir and find absolutely nothing there. So we exit our session and check out our local PowerShell folder and find a test script, no gwmi.ps1. Using psedit to edit it, we take a look at it. It doesn't do much that's useful. but this is just a test script. Let's take a look at our first cool new feature. Copy item now has two new parameters, toSession and fromSession. Let's use toSession to copy that local test script over to the remote Nano Server machine. So the path will point to the local path and destination is the ctest folder on our remote machine. We'll also copy from our remote session, the DISM logs. For that, we'll use the copy alias, which is the short form for copy item. And the path in this case is actually the remote path, the Windows logs DISM log path, and we'll copy to the local folder. So let's do a dir, and we actually find that the DISM log has made the journey safely over. Let's now enter PS session again and see if our local test script has actually made it safely to the remote machine as well. And sure enough, it's there. Once we run it, we actually find that ipconfig ran fine, but getWMIObject produced an error, and the Nano Server rocks string is actually truncated. So let's look at the next cool feature, which is editing remote files. I use psedit to edit that remote script. Not only can I edit the remote script, but we can actually debug the remote script. So I set a breakpoint by pressing F9 and run my script again using F5. The debugger stopped at the breakpoint, and I have full access to the command line. So the first thing I do is get command, getWMIObject, and that gave me an error, is not recognized as the name of a command. For that, I realized that getWMIObject is not supported on Nano Server. Instead, I should be using getSimInstance. So I press Shift F5 to stop the debugger and replace my getWMIObject commandlet with getSimInstance, and press F8 to test out the current line. Now I turn my attention to the truncated string, and I set another breakpoint inside the loop and press F5 again. Once it stopped, I actually realized that I should not be adding +3 to $I. So I press Shift F5, fix that line, that was an easy fix, and run my script again. This time it actually ran successfully. In this demo, we ran Nano Server in a VM on Azure in the cloud and used PowerShell remoting and some of PowerShell's cool new features to copy files from and to the remote machine, as well as edit and debug remote scripts. Thanks for watching.
All right, two last items. Item number one is the Channel 9. Channel 9, if you search Channel 9 and Nano Server, you will see the Nano Server channel. And we have 4 videos up there. I think a couple more will show up in a few minutes. And you can watch everything you saw here again. Next week, we're going to release a bunch more that are more IT Pro focused. You'll definitely want to watch them. Some amazing stuff. Number 2, if you like the session, please fill out the evaluations. And remember, my name is Jeffrey Snover. If you didn't like the session, please fill out the evaluations. And remember, my name is Mark Rusinovich. Just find my name and trash all my sessions. So thank you very much for your time, and enjoy.
Thank you.